Okay, let's calculate the potential due to a collection of point charges. So I have these three charges. They each have a charge of 3 nanocoulombs, and I want to know what is the potential at some point P, and here I've chosen that point to be 1 meter, just in order to give us sort of nice, easy round numbers. What is that charge? What is that potential at that point? Now, to find the potential, I just say the sum of kq over r for each of the individual particles. All right, so that's going to look like this. These are all identical particles. So the potential due to one of the particles, I'll call it V1, is going to equal 9 times 10 to the 9th times Q, which is 3 nanocoulombs, divided by R, which is 1 meter. All right, so that's the potential due to V1, and V1 is equal to V2 is equal to V3 because they're all the same particle, all the same charge, and they're all the same distance from the point P. And then my net voltage is going to equal V1 plus V2 plus V3. Now if I do this calculation, let's see, that cancels. I'm left with 27 volts. All right, so this is equal to 27 volts plus 27 volts for Q2 and 27 volts for Q3. And so that's 81 volts. Now notice if one of these charges had been negative, say for example if Q3 had been negative, then this value would have been negative. And then the net voltage, the voltage of the three charges altogether, would have been 27 volts, right? Let me write that. So if Q3 equaled negative 3 nanocoulombs, then the voltage would have been 27 volts for Q1 plus 27 volts for Q2 minus 27 volts for Q3, and then that would equal 27 volts. So you see if you have a negative charge, then it has a negative potential. It just changes the sign of the potential. It's not a direction, however. It has to do with the energy per unit charge, the amount of energy that you would gain from a charge that was released in that potential. All right, let's look at, I think you have a quick test here. So here, this is very similar. I have two charges. This one is 4 microcoulombs, and this one is negative 8 microcoulombs. And I want to know what is the potential up here on the nose of that little guy. All right, so I'll leave y'all to try that out on your own. And now let's move on. Actually, no, we'll stop